Hello, this is Mr. King, and welcome back. Today's lesson is 7.3 from your textbook, Solving Systems of Equations Using Substitution. The only term we need to focus on today is the term substitution. The definition of substitution is removing one variable from a system of equations by rewriting the system in terms of the other variable. Okay? We'll understand just what this means as we go through some practice problems here. Let's take a look at the first example. Example number 1. We're going to take our system of equations and we're going to find an answer that gives a solution of only one item, one solution. So let's take a look at our two equations. Y equals x plus 4 and y equals 2x plus 1. Well, here's what we know. We know, what does y equal? We know that a y equals a y, so that's the identity, they're the same. So then we must know if y equals y, then this part must equal this part of the respective equations. X plus 4 must equal 2x plus 1. So here's where the substitution comes in. We're going to take this y and we're going to substitute its value in to the equation and make it equal to the second half of the second equation. Okay? So instead of having y's involved, we're only going to have x's because we substituted the value in. So it becomes x plus 4 equals 2x plus 1. Now we're going to go back to what we've been covering for the last month or so. So we're going to solve for x. We subtract 4 from both sides. We get x equals 2x minus 3. We now want to get all our x's on one side, so we take 2x from this side and 2x from that side. We end up with a negative x equals a negative 3. We never want a negative variable, so we divide by negative 1. We get x equals 3. Now, we're going to take our value, x equals 3, and we're going to find the value of y. To find the value of y, we substitute the value of x into both of these equations. So the first equation was y equals x plus 4. We put a 3 in here because that's what our value of x is. 3 plus 4 equals 7. The second equation, y equals 2x plus 1. We substitute the 3 in for the x. 2 times 3 is 6. 6 plus 1 equals 7. We get y equals 7. So we end up with the fact that x equals 3 and y equals 7, or our ordered pair of 3, 7. That is substitution, where you come up with an answer that is only one solution. Let's take a look at our second example. The second example, this time we will come up with no solutions at all. Okay? Our two equations, y equals negative x plus 4 and 2x plus 2y equals 6. Now I want you to take a look at these two, and I want you to tell me which equation is set up better for substitution. Which one would be the easier one to plug in? I'm hoping that you would note that the y equals negative x plus 4, which is already set up in the slope-intercept form and already has y isolated, that would be the one that would be easiest to substitute in. So we are going to substitute wherever we see a y in the second problem, we are going to substitute the value of y from the first problem. So we write down 2x plus 2y equals 6, our second equation, and we're going to substitute negative x plus 4 for this y we have right here. So we have to multiply it times 2 because it's 2y. So we substitute it in. We go 2 times negative x is a negative 2x, and 2 times 4 is 8. Okay? Notice what happens here is we have 2x minus 2x. They cancel out. They're gone. We end up with 8 equals 6. Now you have to think, is that a logical statement? Is that a true statement? That is not a true statement. 8 does not equal 6. And our answer, therefore, is no solution. Here's our Vic. If your substitution work results in a false math fact, such as 8 equals 6, there is no solution for the systems of equations. So if you ever get anything that's just not correct, not logical, such as 8 equals 6, the answer is no solution. And if we graph those two lines, you'll remember from our previous work, we would end up with two parallel lines. Let's look at our last example that's going to give us a result that will find infinite solutions. We have two equations, negative 6x plus 2y equals negative 2. We have y equals 3x minus 1. Which one will you choose to substitute? Would you substitute the first one into the second one, or the second one back into the first one? Which would be the easier to work with? I trust that you would agree with me that substituting y equals 3x minus 1 into our first equation would be the easier one to work through. So let's substitute this value of y in for our y from the first equation. So we rewrite the first equation, negative 6x plus 2 times the quantity, 3x minus 1, we're substituting this in for the y, equals negative 2. 2 times 3x is 6x. 2 times a negative 1 is a negative 2. And that all equals a negative 2. What happens to these two terms, the x's? Well, the negative 6x and the positive 6x cancel out. Okay? We end up with a negative 2 equals a negative 2. You'll see that that is a true statement if you have no variable factors at all here, and you get a negative 2 equals a negative 2, we have an infinite number of solutions. Let's look at the Vic for this problem. If your substitution results in a true math fact with all variables eliminated, we eliminated these x's, we eliminated the y's when we substituted, such as in the example where we have a negative 2 equals a negative 2, then there is an infinite number of solutions. Okay? To summarize, the substitution method allows us to eliminate one of the variables and results in either one solution, no solutions, or infinite number of solutions. That's all for today. Thanks.